I'm Rudolfs Kelle or Rudy Kelle. Uh, Excited to be here. Thanks for having me. I was quite delighted to see my name pop up in the speakers list and get the email. So very exciting. My presentation today is going to be on industrial automation and control system security and incident response. Yeah, go right into it. So a bit about myself. I work mostly in incident response and threat hunting, as well as OT network security. And I'm sure, as a lot of you know, a lot of security, especially cybersecurity, you have to wear a lot of hats. A lot of the times, all of them at once. So that's what I do. I like that part of the job, and makes it fun. And then a bit about CERT.LV. It's the national governmental cert of Latvia. We are under the Ministry of Defense, and we're part of the National Cybersecurity Center. We've been operational since 2006, so coming up on 20 years in a bit. And then we cooperate and collaborate with many different entities. So the National Police Force, banks, financial sector, educational sectors, so universities and schools, and as well as industrial sector, which this presentation is focused on. All right, so a bit of the outline. Now, this is a bit of a technical talk, so I'll spend a bit of time going into many different types of acronyms, pretty much, from IT and OT networks. There are similarities, differences, as well as IACS and SCADA, and what are they? And finally, a bit about the IEC 104 protocol, which is an industrial protocol. Then moving on to motivation. So to extend the incident response capabilities in OT networks, first of all, you need to see what's happening. And to see what's happening in these networks, you need to have vision in them, or see the traffic, understand the traffic. And protocol comes in there. And also to see all of this, we're working on a sensor or a network intrusion detection system, or IDS. Again, different acronyms, but pretty much the same thing. We want to see what's going on, pretty much. Now, to work on that, we have a IACS laboratory where we test it and develop it. And then, so I'll talk about that. We'll talk about the actual sensor and collaboration with the industry as well. So getting into it. So IT versus OT. So I'm sure all of you are aware what IT is, international informational technology. So all of the devices we use daily, both personal lives and job-wise. So your anything, and it uses a lot of different protocols. So everything from internet, so HTTP, to email, so POP3, IMAP, etc. And then on the other side, we have OT, which is operational technology. Now that deals more with industrial applications. So think of factories. It could be anything. So factories, refineries, energy production, energy distribution. This presentation mostly concentrates on electricity transmission. Now there are some similarities between the two worlds, put it that way. They use the same backbone mostly. So IP and TCP stack. So the underlying two layers in the TCP networking layer are the same, but the application layer differs. And there are a couple of key differences, which are listed here. So one, operating conditions. Servers that run the world are kept in very specific rooms. The temperature is controlled, the humidity is controlled, anything so they don't break or stop working perfectly. OT world is quite different. So electrical substations are in very different and very chaotic places. So you can have rain, storms, snows, etc. So different operating conditions. Also, there's a different fault tolerance. I'll illustrate this with an example. So imagine right now, internet gets cut off. It wouldn't really change the things that this presentation too much. I mean, some of you may notice that your WhatsApp messages don't go through, but that's pretty much it. Now, if an OT protocol fails, so for example, the protocol that I'm concentrating on, the IEC 104, we would lose electricity in this building. So we would notice that right away. So the fault tolerance is way higher. No faults are allowed, which changes how the protocol operates. Finally, there's way more OT protocols than IT protocols, and they're not as information on them is not as easily found online as it is with IT. Okay, so more acronyms. So IACS stands for Industrial and Automation Control System. Now you see a graph on your right. IACS pretty much encompasses the whole thing. Here we have the whole OT or operational technology network infrastructure. And on the top there, we have a SCADA or supervisory control and data acquisition part of the IACS. So it is a part of it. It has usually a few parts. In this case, you see a human machine interface, which usually is just a computer where an operator sits and issues commands. Now, whenever the commands are issued, they travel to these devices called RTUs or remote terminal units. They receive the command and they forward it to the end device. Now, in this case, there are few different end devices. There's a temperature sensor, so an operator would just send a command, hey, what's the temperature outside? And the RTU receives it, asks for the data to the sensor, then forwards it back. And then you have another RTU which controls through two programmable logic controllers or PLCs. Now these controllers can connect to numerous different equipment. In this graph, it's some industrial equipment, but in the context of this presentation, it would be electrical equipment. So some kind of a switch or a different kind of a voltage meter, something along those lines. So to talk to these electrical equipment, a protocol called IEC 60870-5-104, aka IEC 104, is used. Now, this protocol is specifically designed for telecontrol of electrical substations, which means it's used pretty much across the world, but it's used extensively in EU. Now, what this means is whenever you have a transmission of electricity, it goes into a substation where, let's say, the substation transfers it from a very high voltage to a low voltage for household usage, or like this building, the voltage regulation and all of that, that's where the protocol is used. It delivers like information or commands or readouts over the application data or layer 7, and it can use TCP or UDP. Mostly it's TCP, and it's over port 2404. Now, since it uses TCP, it also uses IP addresses to identify the RTUs. It also uses the information object addresses. So as you can see, this RTU right here in the red box, there are connected two PLCs. So the RTU needs to understand to which PLC is the command sent. So another analogy would be the RTU would be the IP address would be the physical address of a building, and then the information object address would be the apartment number. So it needs to understand exactly to which apartment to talk to or to issue commands. So moving on. And also no built-in security measures. Quite an important point. It's built to work to have good fault tolerance and operating conditions, etc. But it's not built with security in mind. Hence, we're looking at it. That's one of the reasons. Okay, so we've established that to have a good incident response, you need good visibility. Hence, you need a way to see inside the traffic. Hence, we're creating this OT sensor. Now, I've explained how the protocol works. Now, also how it's adapted. If it's adapted in EU, it's also adapted widely in Latvia, and it plays a crucial role in critical infrastructure operation. I'm sure you can imagine what could happen if the protocol fails or there's an attack. The consequences are depend on that can be very severe for some successful attacks. Now, to have visibility in OT networks, it is difficult to have it because most open source solutions, well, they don't provide support for OT protocols. So, for example, Zeek. I'm sure people know have heard of Zeek. You can see into different HTTP traffic, email traffic, just general connection TCP-wise, but there is no built-in support for most OT protocols, including the IEC 104. That's why we have the laboratory. That's why we're working on it. That's why we're developing a way to look into it. And the end goal for us is to have a generic OT sensor. So not just one protocol, but a lot of different protocols that we can understand and interpret the traffic and events. Now, I've covered that's how the protocol is used. And we're not developing the sensor around this particular protocol just because it's used a lot. It also has been seen in past attacks. End of 2016 in Kyiv, Ukraine, a transmission substation lost power, and a large part of the city was left without power for I think a few hours. Now, this attack was later coined as crash override. I think Dragus investigated it. Yeah, so the chain was as follows. The attackers got access to the IT network. They established persistence, and they pivoted to the OT network. And they executed malware. It was developed before, but it was put on the network and executed. It enumerated and set the IOAs, so information object addresses, to toggling open and closed states, which basically means they turned the flow of electricity on and off, which caused havoc pretty much. Some screenshots here. So the left one is a screenshot of the configuration file of the malware used. You can see that there's a target IP, target port, and some other configuration strings. And the screenshot on the right is a bit more interesting. It's actually from the traffic captured in when the attack occurred. And you can see here that it's actually using the protocol that I mentioned before, IAC 104. And it uses this string. You can see the string CSCNA1, which basically which translates to single command, which is how the malware turned, or how the malware interacted with the PLCs. It told the PLCs, hey, turn off or on, and etc. Now, this attack was attributed to Russian APT at the end by CISA. And it's a clear example that that this protocol is used. Now, that was 2016. Also, December 2021, a malware sample was uploaded publicly, which also had similar functionality to the one that I described. It was labeled Cosmic Energy. Okay, so moving on. So just to recap, we know we want to see in this traffic. We know that IEC 104 is used. Okay, we want to look into the traffic, etc. So to do that, that's not the reason why the laboratory was built, but it's one of the functions of it. So we do have an IACS laboratory. It was designed to replicate different parts of the Latvian energy grid. So production, both production, transmission, as well as storage. You can see there it's split into 8 segments. The top 4 are for energy, storage, transmission, and electricity creation. So we have, and it mimics, so the devices there are the same as in real life in different parts of the gas transmission grid. So these devices would simulate opening and closing of valves, gas flow, and gas storage as well. We have a natural storage where gas can be stored, as well as energy production. And then the bottom 4 squares are for electricity transmission. Well, 3. The control station is SCADA. So it pretty much gives commands to the other 7 parts. But the other 3 bottom sections relate to electricity transmission. So one is high voltage to our lower voltage substations. So think of city household transmission. So many different devices, many different logical connections, and many different protocols. They're implemented exactly as in real life, without, of course, the physical distances between different parts of the grid. Also, this lab was designed so we can tap into any part of the network of the whole system. There are little switches that you can plug into. You can read the traffic, you can inject traffic, you can simulate attacks. Also, all of these sections can be removed and run separately. So we do a lot of device testing and other stuff, but different presentation. Okay, so besides the physical lab, we also have developed a virtual lab specifically for the IEC 104 protocol. Now, previously, the physical lab, it's very good to see very detailed stuff, detailed events. So whenever it's controlled by, like someone clicking and sending a single command, but to simulate a large amount of traffic, it's not really meant for that. So a virtual lab was built to do that. It simulates large amounts of IAC 104 traffic. Now, there are 2 parts to it. You have a TCP server and a TCP client. Now, the TCP client is a virtual remote terminal unit, or RTU, which generates the IEC 104 traffic. And it supports 5 redundant groups with 2 hosts, so 10 hosts total. And it can generate any type of measurement data, or it understands as well. It also understands commands that are sent to it, both single and double commands. Also supports sending spontaneous signals. So it's very programmable and modular. You also have TCP server, which acts as a collector for all the data that the client sends. It can also handle, it can handle 100 RTUs and also redundantly using MQTT. Yeah, so virtual lab, to recap, need to simulate a large amount of traffic, just so we can test the OT sensor's capabilities. So a bit about the sensor. So right here, there's a graph of a very simple IACS system. You have a SCADA workstation where an operator issues a command to an RTU, which then forwards the command to any of the 3 PLCs. Yeah, and then the PLC executes the command, whatever it may be. Now, this command is sent unencrypted using the IEC 104. There's no authorization mechanisms on the protocol, and the security is most of the times implemented using by the vendor. So RTUs, they're sold by different vendors, and then the security is implemented, depends on how the vendor implements it. Also, since it needs to be configured, so it is part of, it should be part of engineer's job to configure it correctly so there is no security holes. Now, what we want to do is put a sensor between there so we can just see what's going on. Now, next slide, I'm going to zoom into the actual sensor. So what it actually does. So under the hood, it's based on Zeek. And it works as follows. So whenever it gets traffic from the SCADA, it's split into packets, and basically the Zeek engine, it doesn't understand it by default, but there is a plugin for Zeek called Spicy, which allows to teach Zeek how to interpret different protocols that are not enabled by default. So the Spicy allows us to determine whether the packet is part of the IEC 104 protocol. If it is, I mean, there's an in-between step to log the traffic, but at the end of the day, the traffic is logged by the Zeek script file. Yeah, so it performs the most important action, it logs it. So, and whenever that's done, you can do whatever you want with that log file. You can forward it to Splunk, to Elkstack, to different log collectors, up to your imagination. Yeah, so what exactly are we looking at for the protocol? In general, there are three types of packets carried by the protocol. I, S, and U. S and U are more of a, hey, are you alive? Give response, and then it's a very chatty protocol. But the actual commands and are carried by the I format packets. Now, these I format packets they carry the most crucial data. And in total, they can carry up to 100 object codes. Now, object code means just some instruction, put it that way. So there's 100 different instructions ranging from give me a voltage readout, give me a voltage readout every 2 minutes. It's very broad. But I've highlighted two object codes here, CSCNA1 and CDCNA1. The CSCNA1 was seen in the past attack slide I had before. Both of these object codes relate to issuing commands, meaning if a PLC receives one of these two commands, it would either close or open some circuit, thus changing the flow of electricity, thus turning it off and on, etc. So I've highlighted these two because they're the most straightforward, put it that way. Now, ideally, we would, that's what we do. We want to understand all of the object codes, but these are just for an example. Okay, so a bit about a threat scenario we want to look at, that we are looking at. We're looking at a scenario where a threat actor has access to the OT network and communicate with the RTUs. Now, to accomplish this, it's not easy. It's quite of a it's a hard attack, but there is a possible chain of attacks. It's similar to what the attack 2016 we saw. For example, attacker could gain initial access or initial footholds in the IT network. Numerous ways to do this. I'm sure all of you know phishing, supply chain, vulnerability, etc. All of the usual ways that attacks usually happen. And then the attacker could pivot to the OT network. Different ways to do it. For example, I've listed data historian. So that's like a logging system for the OT networks. And finally have poor practices by the IACS engineers, which also happen in IT worlds. Configurations are almost never perfect, so attacker gets access to the attacker gets access to the traffic and can inject traffic and control the PLCs and RTUs with the knowledge they've gained by reading the traffic. Okay, so talked lots. So just to summarize, we have an OT network, and we have an IACS system, and in it we have SCADA system, which issues commands. The commands are issued by engineers, and and then these commands are then forwarded to remote terminal units or RTUs, which forward the command to PLCs with the IAC 104 protocol. Now, to understand this, we're doing network packet dissection. We'll look at different object codes, so the single and double commands I mentioned as an example, and we're performing some action. We're logging them and analyzing them, if needed, blocking them. So to overview, this is the actual sensor, how it's implemented on a device. So we see a network traffic, we mirror it to the sensor, so some Linux box, which has and you have Zeek and Suricata running there as on Docker containers. So they're easier to transform and understand. And then we also have some detection rules for Suricata, since it's industry standard. They complement each other, so Zeek and Suricata. Yeah, so the traffic gets analyzed. So Zeek logs it, Suricata creates events. Those events are then sent to the elk stack. So if needed, packets can get dropped as well. And then finally, we have a analyst workstation where they can look at the traffic, interpret it as they need to, and act upon it. Now, one important thing I didn't mention before, but I remember now. So this can be very useful, not just for incident responders, but for OT engineers as well, since they don't really have any well, they have some understanding on what's going on, but this type of protocol analysis would help them as well to understand when people are sending commands, what issues might arise, and things like that. Yeah, so workstation. Now, this is a screenshot of the dashboard. I guess you can kind of see it. A couple of things I want to point out. So number one, this dashboard concentrates on the CDC NA1. So the double command dashboard, so you would only look at those object codes. So building a dashboard, so this is Kibana, building a dashboard for all of the different object codes would be dashboard could be very big and hard to look at. So this just looks at one object code, which is one of the most important ones. We have here like some statistics about RTU IP addresses that the sensor has seen, as well as the SCADA IP addresses. Now there can be multiple SCADA systems issuing commands, so hence there are two here. And another field is here. So as I mentioned in the threat scenario, we look at a case where a rogue attacker gets access to an internal network and starts issuing commands. Now, for this to happen, a new IP address would appear, and hence it would pop up there. So if it's a new IP that's not in the whitelist given by the administrators, it would be seen there. Yeah, so generic dashboard. Ideally, there will be multiple dashboards looking at multiple parts of the protocol. Okay, moving on. So conclusions and future. Now the OT traffic, as I touched upon multiple times, it's difficult to interpret because it is not really documented too much. It's of course there are ways to see it, the ways to analyze it, but it's not covered by open source solutions. So you need to invest a lot of time to understand it. The next point, practical knowledge, that's very important because I can read some stuff about the IAC 104, but I mean, I don't know how it's used in real life. So at the end of the day, you need someone to who can tell me and the team, hey, don't look at that, that's useless, look at this, things like that. So we have someone like that on the team, which helps a lot. Now, for the future, we want to look at different ways to analyze the IAC 104 traffic. I talked about the object codes, but there are different methods that we are developing as well. And also we want to repeat this process for other OT protocols used in the industry. So ideally, as I touched upon, you want to have a box that can be used by any Latvian energy producer, user, whatnot. And then finally, collaboration. So since this is quite of an unexplored field, collaboration with the industry is crucial. It is a must pretty much. And also there are different ways of using the protocol. It depends on how the infrastructure is set up, how the IACS is set up, how the vendors are have set up their devices, their RTUs. So it is a must to collaborate, and that's what we are doing. We're collaborating, we're working with the companies, so we can develop a solution that works for them. So obviously we can build something, but if it's not useful for them, what's the point? Okay, so presentation's over, but a quick commercial for our conference. That's going to be in this October. Hopefully, that's right now is the save the dates phase. It's the largest cybersecurity conference in the Baltics. We usually have 500 members on site and 3,000 online, so hybrid mode. It is a 3-day program with 3 parallel sessions. So we have a political session, so more higher discussions and talks. Also a technical session, so more talks like these, like mine, and another session where I think this year is going to be workshops. Now we have both local and international experts. And finally, it is free. So if you join and get accepted, no payment needed. We'll accept the flights, of course. Yeah, that is all. Thank you.
Thank you. So we've got a few minutes for questions.
Hi, Paul Ditto from the Jersey Cybersecurity Centre. Thank you for a really interesting presentation. I looked at something similar, and one of the things that I wanted to ask your system, firstly, does it have any anomaly detection built in? Because ICS systems go through an event loop each time. So in your scenario where you had your Russian friends messing with the control signals, if you had some sort of anomaly detection, that will, in my brain, would say that should fire, in that scenario, because it's running constantly like this, and then it's suddenly doing other things. And secondly, if you got to the stage of going out to your power company saying, hey, we've got this sensor, we'd like to deploy it in your network, have you had any pushback and sort of legal issues with responsibility, for CERT.LV, because you're providing something, you're possibly introducing a moral hazard to CERT.LV, because if that goes wrong and it causes something with the power.
Yeah. Thanks for the question. So the first part, yeah, I should have mentioned this. I forgot. Since we have the raw log files, you can implement different types of detection logic. You can do rule-based, anomaly-based, ML-based. Right now, we are doing more of a rule-based approach, or rule/anomaly-based. We are planning and we are doing some steps on the ML side, which would also help in the industry. Now for the legal issues, well, one, we are creating it so we only see the mirrored traffic, so we can't really affect the traffic, so it wouldn't really, we wouldn't mess anything up, but we haven't had any really pushback. Well, of course they want to talk, they want to understand, but at the end of the day, the engineers there want to see the traffic. That's the point I mentioned before. Like, it's useful for them not just for a security perspective, but for an operational perspective as well. So they want to see the traffic.
Okay, I think that is time. Thank you all for coming. One final reminder to fill out the session review either on the app or online. Thank you all for coming. One more round of applause.